This video is on coordinate geometry, plane shapes. So marking geometry diagrams is very important to be able to do and know what the symbols mean. To show that two line segments are congruent, we need to know the symbol for congruent and we need to know what it means. So congruent means, I'm going to write it over here, it's when you have the same shape and the same size. The symbol for congruence is when you have an equal sign and then a tilde on top, because this shows the same size. The equals shows the same size. The tilde shows the same shape. So we have the congruent symbol, same size and same shape. On a graph, congruent sides have the same distance. So in order to find that, you would use the distance formula. So distance, we're going to use the distance formula or the Pythagorean theorem on the graph. Pythagorean theorem on the graph will be a little bit easier because we can count horizontally and count vertically and create a right triangle. So the symbols that we use to show it when we're given a segment, the symbols we see are going to be tick marks. Now we can have one tick mark, or we can have two tick marks or three tick marks, whichever one happens to be the same for the other segment. So if I have two tick marks on this one to show that this segment is congruent or this has the same distance as this segment, I would have two tick marks on that segment as well. So the amount of tick marks show that these have the same distance, so these two segments are congruent. That means that the lengths are equal in measure. To show that two lines are parallel, which the symbol for parallel are two lines looking like this, where they're not touching, is when on a graph the parallel sides have the same slope. They have the same slope but different y-intercepts. So to show slope, we're going to use the slope formula, which is change in y over change in x, or rise over run on a graph. So again, change in y over change in x. So to show this on our segments, so if we have, or lines, if we have two lines graphed, to show parallel, we would have arrows inside of our lines or on our lines. They might also have little triangles instead, but the amount of arrows, the same way with congruence, the amount of arrows show that these two are parallel. If this one had two arrows and this one had one, they would not be parallel. Then to show that two lines are perpendicular. Perpendicular, we're going to also look at the slope, but perpendicular symbol is when you have, it's an upside down T. Perpendicular gives us right angles. To show that, our picture will look like this. It must have the little box in the corner there to show that they're perpendicular. On a graph, perpendicular sides have opposite, that means one positive, one negative, reciprocal slopes. So 3 over 5 is a reciprocal of 5 over 3. So again, we're going to look at the slope. So change in y over change in x. As a reminder, slope is change in y over change in x. And distance, we're going to use distance formula or Pythagorean theorem, which is a squared plus b squared equals c squared. So we're going to take the square root. So distance is equal to the square root of a squared plus b squared. So the distance of our horizontal line in our right triangle and the distance of our vertical line in our right triangle. So some important information we'll need to know is the plane figures. We're going to focus on triangles and quadrilaterals. So triangles, we have multiple types of triangles. We have a scalene triangle. So the property of that is that there are no congruent sides. All the sides are different. All the sides are different in distance. So we have no sides have the same distance because they're not congruent. So it would look something like this. These are not congruent. So we would have 1 tick mark, then 2 tick marks, then 3 tick marks. So all 3 of those are different sizes. Isosceles, an isosceles triangle has 2 congruent sides, meaning that 2 sides have the same distance. So a picture of this would have a triangle, and we'd have tick marks, the same amount of tick marks, on 2 of the sides. Now, it can be any of the 2 sides, but they have the same amount of tick marks. So the third side would not have the same tick marks. So we might have 2 tick marks down there. An equilateral triangle is where you have 3 congruent sides. That means that all sides in a coordinate plane, all sides have the same distance. So this would be an equilateral triangle by showing that all 3 sides have tick marks, or all 3 sides have the same distance. Now, some important information about the angles in a triangle. If it's equilateral, if all 3 sides are congruent, then this will also be called equiangular, meaning all the angles are also the same. Because of the congruent sides in this one triangle, all 3 of these angles will be the same. They'll all be 60 degrees. Now, because we have, and that's because we have tick marks. We have the same tick marks. On isosceles triangles, same thing kind of happens. The angles opposite of those tick marks will be congruent. So we can actually say that the angles opposite the congruent sides are congruent. So if I'm looking at this tick mark, this congruent side, the angle opposite that would be here. Here's this tick mark on this side, the angle opposite that would be down here. That means that these 2 angles will be the same measurement. We don't know what they are, but they do have to be the same. Now, because on the scalene triangle, we don't have any of the same amount of tick marks, that means that none of the angles will be the same. Scalene will have no angles are the same. So it kind of goes along with the sides. If we have all sides the same, then all angles are the same. If we have 2 sides the same, then 2 angles are the same. If no sides are the same, then we have no angles are the same. Then we also have acute, right, and obtuse. This goes along with the angles. An acute triangle is when we have all angles are less than or smaller than 90 degrees. Smaller than 90 degrees. So it would look like an acute triangle has all the angles that are going to be smaller than 90 degrees. So no right angles and nothing bigger than 90 degrees. In the coordinate plane, we won't really use anything to show that. We would use a protractor to measure the angles. For a right triangle, 1 angle is going to be a right angle. So 1 right angle, which means that 1 angle will be 90 degrees. So we will see that with the little box in the corner of our triangle. This shows us that it has a right angle. But to see that right angle, we actually will see that in our coordinate plane, because a right angle means that they are perpendicular. So we'll see that inside the coordinate plane. We'll see that two sides are perpendicular, which means that they have opposite reciprocal slopes. So one might be a positive 3/5, the other would be a negative, that's what the opposite is, reciprocal is 5/3. Those would be opposite reciprocal slopes. We'll see that in the coordinate plane. And then an obtuse triangle is when you have one angle, because you can only have one angle, that is like this, is more than 90 degrees. You can't have more than one angle doing that, because in a triangle, the angles add up to 180. So if I have two angles that are bigger than 90, those are already bigger than 180. Therefore, it's not a triangle. So it looks more like this. So we'll have bigger than 90 degrees here. That angle is bigger than 90 degrees. And we won't really see anything in the coordinate plane to show us that. One last thing about triangles that we need to know is how to find the area of the triangle. Area is equal to, of a triangle is 1/2 times the base times the height. You can also see it as area is equal to base times height divided by 2. All of that. And remember, it's going to be units squared, because it's going to be a unit times a unit. Base is a unit of measure. Height is a unit of measure. So it will be units squared.